In section 3.2, you will solve linear systems algebraically. And the first example we'll look at is example 2 here. We're going to use the substitution method. And to use the substitution method, we need to solve for one of the variables in the system so that we can substitute into the other equation for that variable. You want to choose a variable with a coefficient of 1 or negative 1. So I'm going to solve for x in this first equation by adding 3y to both sides. Then I can substitute into the second equation for x, 3y minus 5. Okay, distributing on the left, I get negative 6y and positive 10 plus 3y equals 10. And adding like terms on the left, negative 6y and positive 3y is negative 3y. And subtracting 10 from both sides, I get 0 on the right. Now dividing both sides by negative 3 to get y alone, I find out y is equal to 0. Once I know y is equal to 0, I can go back to that first equation where we already solved for x, and I can substitute 0 in for y to get my x value. 3 times 0 is 0, and 0 minus 5 is negative 5. So x is equal to negative 5 when y is equal to 0. Negative 5, 0 is the point of intersection of these two lines on the coordinate plane. Now if you look at example 1, this one is nice because y is already alone, y is already solved for, so all you'd have to do is substitute into the second equation for y and then go ahead and use substitution to solve that method or solve that system. The second method that we're going to look at is elimination. And again, let's take the second example here to use elimination on. In elimination, we want to add the two equations together to eliminate one of the variables. Our coefficients on x would have to be 10x and negative 10x in order to add them together to get 0. Or on the coefficients on our y terms would have to be 15y and negative 15y. So I'm going to choose to eliminate x. I'm going to multiply both sides of this first equation by 5 in order to get 10x. And I'm going to multiply both sides of the second equation by 2 in order to get negative 10x. So distributing, 5 times 2x is 10x. 5 times 3y is 15y. And on the right-hand side, negative 1 times 5 is negative 5. Now distributing through the second equation, 2 times negative 5x is negative 10x. And 2 times 5y is 10y. 2 times 15 on the right is 30. So now I'm ready to add my equations together to eliminate x. 15y and 10y is 25y. And on the right-hand side, negative 5 and 30 is 25. So to solve for y, we divide both sides by 25. Y is equal to 1. Now to find x, I go back to either equation. It doesn't matter which one, so I'm going to take the first one and substitute that value of 1 in for y. Okay, so I get 2x, and 3 times 1 is 3 equals negative 1. I'll subtract that 3 from both sides. 2x is equal to negative 4, and I'll divide both sides by 2 to find out x is equal to negative 2. So when x is negative 2, y is 1. This is the ordered pair that satisfies that system of equations. If you look at the first example, we would only have to multiply the second equation by 3 in order to eliminate our y terms. We wouldn't have to change both equations because we'd have negative 6y, and if we multiplied the second equation by 3, we'd have positive 6y. So we could easily eliminate our y terms in that first system and then use elimination to solve. In these examples, we're going to solve the system using any algebraic method. So I'm going to choose to use substitution in this first example. I'm going to solve for that 1y, remembering that I want to solve for a variable with a coefficient of 1 or negative 1. So I get 3x minus 5, and now I can substitute into the first equation for y. So I get 9x minus 3 times y, which is 3x minus 5, and it equals 15. So I'll distribute on the left and get negative 9x plus 15. And then when I go ahead and add my like terms on the left, 9x minus 9x is 0, so I'm left with 15 equals 15, which is a true statement. When my variables drop out and I end up with a true statement, I know that I'm working with the same line on the coordinate plane, and I have infinitely many solutions. Okay, in the second example, I'm going to use elimination, and I'm going to choose to multiply the second equation by 2 so that I have positive 6x added to negative 6x, and I'll get 0 when I add them together. So I'll distribute through the second equation. 2 times negative 3x, negative 6x, 2 times 2y is 4y, and on the right hand side 7 times 2 is 14. Now I'm going to add that to 6x minus 4y equals 14, the first equation. And when I do, I see that not only do my x terms sum to 0, but my y terms also sum to 0, and all that's left on the left hand side is 0. On the right, 14 plus 14 is 28. But 0 doesn't equal 28, that's a false statement. So here when my variables drop out and I end up with a false statement, I know that I have parallel lines and no solution. Okay, in this application problem, a citrus fruit company plans to make 13.25-pound gift boxes of oranges and grapefruits. Each box has a retail value of $21. Each orange weighs 1/2 pound and has a retail value of 75 cents, while each grapefruit weighs 3/4 pound and has a retail value of $1.25. How many oranges and grapefruits should be included in the box? So let's let x be our number of oranges, and let's let y equal our number of grapefruits. So the totals in our problem is the weight of the box, 13.25 pounds, and the cost of the box, which is $21. So to get the total weight, each orange weighs 1/2 pound, so we'll multiply 0.5 times the number of oranges, and we'll add that to 0.75, the weight of a grapefruit, times the number of grapefruits. So that will total 13.25 for our box. Okay, then to get $21, we'll take 75 cents times the number of oranges plus $1.25 times the number of grapefruits, and that sum of those products should be $21. So here's our system of equations. I'm going to choose to use elimination to solve this system, and I'm going to choose to eliminate x. Remember, you have a choice. You can eliminate x or y. I'm going to multiply 3 times both sides of this first equation, and I'm going to multiply -2 times both sides of the second equation. So distributing, I get 3 times 0.5x, that's 1.5x. 3 times 0.75y is 2.25y. And 3 times 13.25 is 39.75. Okay, distributing -2 through the second equation, -2 times 0.775x is -1.5x. And -2 times 1.25y is -2.5y. And on the right-hand side, -2 times 21 is -42. So now I'm ready to add my equations together to eliminate my x terms. And when I add my y terms together, I get -0.25y On the right hand side, I get more negatives than positives, negative 2.25. Okay, and dividing both sides by negative 0.25, I find out that y, or the number of grapefruits, is equal to 9. And now that I know the number of grapefruits is equal to 9, I can go back to either equation, and I'm going to choose the first one to solve for x, or the number of oranges. So I'll substitute in 9 for y, and I'll solve for x. So I'll multiply first, and I get 45, 63, 67, 6.75. And then subtracting that 6.75 from both sides, I am left with 0.5x on the left, and on the right I have 6.5. So dividing both sides by 0.5, we find out that the number of oranges in the box is 13. So how many oranges and grapefruits should be included in the box? 9 grapefruits. Oops. And 13 oranges. Include in your notes of this video guided practice problems 1, 3, 5, and 6 found on pages 161 and 163 of your textbook.